conference will now be recorded.
Okay, so welcome to Mohansh Technologies, and I'm opening Collaboratory now. And today we will discuss about three important concepts like decorators, iterators, and generators. Let me go through the decorators. Three important functions basically, and interviews also. On top of this, a lot of questions are going to be happening. So in Python, there are important concepts like decorators, iterators, generators. Decorators, decorators, and one more is iterators and generators. Okay, so we will see one by one. First of all, we will see about the decorators. How decorators are going to be. Okay. Now let me write down the function. Let me write down some theory for that. What is decorator? Decorator is a function. Decorator is a function that takes another function as input. Decorator is a function that takes another function as input. Another function as input and extends behavior. And extends behavior. And extends behavior without modifying the original code. Without modifying the original code. Okay, how we can able to understand this decorator? So decorator function, how to use decorators, I will tell you. First of all, we need to write a function. First of all, we need to write a decorator function, and we can able to use that decorator function to extend the another function as input. To extend the another function as input and extends the behavior without modifying the original code. So previous function code automatically comes, and existing function code also works using by the decorators. So let me write down a simple function here. Okay, so example, def, let me write a decorator function. Decorator function. So this is normally a decorator function. I am defining a decorator function over there, and here I am passing the let me use this code. Decorator function. There is the original function. We can use the original function as, and the def wrapper function. We write a wrapper function here and print before original function, and we call the original function here. Okay, original function is the parameter, right? Original function is the parameter. So when we use this original parameter function, and here wrapper function containing two prints: before original function, after original function. Before original function, after original function. So original function is calling. So what is the output of this original function? We will see now. What is the output of this original function? We will see now. Okay, so very simple, straightforward. This particular wrapper function is returning a wrapper function. Wrapper function is returning some wrapper function. When the decorator function is calling, how the decoration function is calling, how we can call this decorator function. Now there is a syntax to work with the decorator function. So at the rate decorator function. So whatever the function you have, that you need to call here. At the rate decorator function. So this is something like a decorator. This is something like a decorator. But I will write my own function now. Def say hello, something like say hello. Let me write a simple function, say hello. And this is going to be having some code, something like a print hello Mohansh. Print hello Mohansh. Okay, now I need to call which function? Now I need to call which function? I need to just call the say hello function. Now I need to call the say hello function. Just call say hello function. What is going to be happening here? I'm just calling the say hello function. What is the output of the say hello function? First of all,
Hello Mohansh.
hello Mohansh. Yes, hello Mohansh is going to be the original function. and original function have some decorator function also. Original function already have some decorator function also. And what is the decorator function contained with? Decorator function contained with the wrapper function. Function contained with the wrapper function. So wrapper function is returning by the decorator function. Wrapper function is returning by the decorator function. So here we will be having a print before original function, and one more thing, print after the original function. So when you call this particular function, first of all execute this, connect it to the cloud. It's a very simple concept, how we can use the decorator functions and what is the purpose of the decorator functions in real time also I will tell you. Okay, let me execute the decorator function first of all. So that was executed. Now I need to use the decorator on top of the original function. I am calling the original. So can you see the output? What is happening here? Before original function is calling, and after that hello Mohansh is calling. My original function is also calling. My original function is hello Mohansh. So before that decorator function is calling. Decorator function is this one, before original function and after original function. So this is my original function. Original function is say hello. Say hello executing. Whenever you call the decorator, original function is this one, say hello. So say hello is calling in middle. Why? Because before that there is something like before original function and after original function. That is some kind of wrapper functions. That is kind of wrapper functions. This is kind of decorators. So why we need to use the decorators? Where the decorators are going to be using? Okay, let me write down for that.
Mohan's, before that one query,
Please go ahead.
uh, we didn't mention anywhere as original function, but still it takes as say hello as a original function, alias.
Yes, inside this decorator function, original function is a parameter. See, original function is a parameter. That parameter is this one, say hello. Say hello
Okay.
going as original function.
Okay.
Say hello going as original function.
That means
That is
again
our,
it is coming from decorator function to original function. It is printing whatever the statements it is having. Then again
yes,
going back to wrapper function.
yes, exactly. Yes,
Okay.
exactly. So the decorator function say hello is actually taking as the original function parameter value. So decorator function is actually defining here, and I'm calling the say hello only. I'm executing the say hello only.
Mm.
When I'm executing the say hello is going to be inserted here. Inserting here, and wrapper function is returning, and this is what executing. Before function is calling, and original function is calling, and after function is calling. See, this is the decorator.
And is it a predefined function, predefined keyword like original underscore
No,
function?
no, 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 no. That is your wish. This is the parameter stuff.
Okay. Okay.
Parameter is your wish.
And even the wrapper function also, it is like just a parameter we have provided, right?
Yes, yes.
Okay.
Why wrapper
There,
function
there
is
is there is there is no parameter for the wrapper function. See, we need to call. We need to call. That is the why reason we need to write a wrapper function. We need to execute, right?
Right.
I'm not returning the original function. I'm not returning the original function. I'm just writing the wrapper function to execute the original function. So writing a wrapper function, inside the wrapper function, I'm going to be having a before original function, then original function parameter, and a print after function. Both everything is calling one by one. But you are calling say hello only. You are executing say hello only. When you execute say hello is going to be sitting into the original function value. Here, this is the say hello. Why? Because of first output is this. Second output is original function. What is the
Mm.
second output? Can you see? Hello Mohansh. And the third output is this. Why? Because this wrapper function is executing. When you call the decorator function, wrapper function is executing.
That means in the decorator function, some other function is mandatory mode.
Compulsory.
Okay. We can't print before the wrapper function any statements.
Yes, yes.
Okay.
say like def decorator underscore function brackets original function you have written, no sir. Uh,
Mm-hmm.
Under that without dev wrapper function, can we write print before original function print after?
Okay. You are saying like this, huh? Uh,
Yeah, yeah.
print.
I mean, def wrapper function you comment it,
Before,
sir.
yeah,
Ah,
no issues, no issues. Before wrapper function, I will write here. Before wrapper function. Before wrapper function, I want to write a one more print
yeah.
here. Okay, this is outside. Okay, let me
Correct.
execute this, and this is not indentation error. What is the indentation error? I will say like,
Def.
let me go. 1 second. 1 second. This is okay, and for this def also should go like this. Hmm. Now you can execute it. Again, indentation does not match to the outer lines. Okay, return also we should go like. Okay, that is executed, and now you can call this. Now can you see before wrapper function also I can able to print something. That is your wish. Whatever you want, you can print outside of the wrapper function also. But wrapper function, why I'm taking the wrapper function to call the original function, or you can call the original function directly. You can call the original function here.
Okay, that means under decorator function, that is optional only. Other functions are optional only, basically.
Optional, optional, optional. That is
No,
not
what,
important.
what is the need of wrapper function, sir? I am not
I
catching
will
it.
tell you. I will tell you. So this kind of wrapper functions are important in the concept of logging in the real time. Logging in the real time. At the same time, this is very important for the authorizations. Authorizations. Whenever you connect with the systems, authentications, authorizations, both different concepts are there. Authentication is something like a username enter, password enter. Authorization is something like accepting the username or accepting the
Like
some
particular role, sir.
particular roles.
Okay,
So this
got
is some particular situation. This kind of wrapper functions are needed. Username, passwords, checking, okay, and validations. Username, password validations. That is kind of authorizations, and measuring the execution times. So some kind of timer is running in the background. So that kind of situations, measuring time in background. So you will find out different kind of examples on these particular concepts. How wrapper functions are working with the how this decorator functions are working with the logging, how the decorator functions are working with authorization, how these decorator functions are working with measuring time in background, and one more kind of debugging concepts also we will use this. Debugging concepts also we will use this. But we'll try to understand how this wrapper function is working here, how this decorator function are working. Okay, so let me write the simple example for the timer. If you want, I will write down. Let me write down the timer example for this. How the timer is running with the decorator functions. Let me, if you want to work with the timer, first of all, you need to import a module called time. Import time. Without time module, you cannot able to get the time values and all. Okay, let me write a function, uh, decorator function. Def timer, timer decorator, timer decorator. And here in this timer decorator, I need to call a parameter, anything, something like a function. Okay, so inside this, I need to write a wrapper, def wrapper, and for this wrapper, I need to go start. There is a variable called start variable. Start is equal to time dot time. I can say like time dot time function. So time is going to be running over there. After that, I need to call the function. We have the function right already. So and I'm calling the function, and end is equal to start and end both are I'm going to be writing. So end is equal to time dot time. So start time and time both I need to calculate here. Start time and time I need to calculate here. So start is equal to something and end is equal to something. Finally, I need to go with the print execution, print of execution time, execution time, execution time. I need to calculate the execution time. Then and comma, you can go with the end minus start. End minus start is basically execution time, right? So how the function is going to be compiling like start, start. Where is the what is the keyword? Start only, na? Okay. So then I just go with the seconds also I want to see, and I can go with the seconds. So space seconds. How many seconds got taken to execute this kind of things. Then finally, you need to return the wrapper. Okay, so how to return the wrapper? Return wrapper. Wrapper. What is the function name? Wrapper. Huh? Without spelling mistakes. So please go ahead. Return wrapper. Now this I need to execute first. This got executed. Import time. First of all, time module is important to execute the times, time related functions and all. And what is the execution time? I want to check it out. What is the execution time of this program? I want to check it out. For that, I am taking a one simple decorator. And now, what is the parameter here? I need to call a decorator first. So whatever the function we are going to be executing parameter, that I need to write down now. Okay, write down the original function now. So first of all, the decorator is needed. Okay, at the rate, what is the decorator name? Timer decorator, right? Decorator name is timer decorator. Just define the timer decorator. Define the timer decorator.
Mohansh,
Let
why we are taking another cell? Can't we write in the same cell?
We can write in the same cell. You people confused. That is our reason I'm taking this.
Okay, okay, okay.
A new function. Okay, I'm writing a new function here, and for this new function, let me go with the time dot let me give the method called a sleep method. Sleep of 2 or 3 seconds, whatever you want. Okay, then I can go like print done. Print. Let me show this one. Call the new function. Call the new function. Whatever the new function I'm taking here. Call the new function. Just execute it. When you call the new function, what is going to be happening with? When you call the new function, what is going to be happening with? Okay. Can you see and observe what is going to be happening with this? Okay, done. Execution time is 3 seconds. Okay, if I give 2 seconds here, call the function. This function execution time is this much. I'm giving time sleep is 2 seconds. What is happening here? The same. One more example for the decorator here. One decorator I'm taking like a timer decorator, and inside that I'm writing a wrapper function, start time and end time. Start time started and end time ending. Before this, in between these two things, I need to call the function that is something like a sleep time. So what is the sleep time? I'm giving 2 seconds. So 2 seconds it is waiting, and after the 2 seconds, the function is going to be execution. So execution time is end minus start, and seconds also given. So in the kind of debugging concepts also, these kind of decorators can be used, and this is a kind of one example for the timer. This one measuring the time in the background. I just want to check it out how the time is going to be working in the background to execute the situations or analysis. Data analytics part. This is a very important concept. Am I clear? Let me go for iterators. Iterators are simple. There are two functions like iter and next. You try to do practice with the number of examples, you can able to understand this. Next, I go through iterators. Okay, iterators. So there are two important concepts which are going to be working with iterators. Iterator is an object.
Mohansh, can I stop for a second?
Yeah, please go ahead.
Yeah, in the decorator main function, I mean, above if we see a new function we calling, right, we are having, right. After that at the rate time decorator, always we should have only single function or else multiple functions
Single
also.
single function, single function, single function. It's a one parameter only I'm taking here. You
Right.
can, if you want, you can take multiple parameters. If you write down more and more functions, you take as multiple parameters here.
Oh, we can go with multiple functions as well by giving
Yes,
multiple parameters.
yes, exactly. This decorator is going to be working for the multiple functions also, not only the single.
In a in layman talk, can we call this as a function is calling another function?
Function is decorating by the another function, not calling. Function is decorating with another function. This new function is decorating with this one. So this
Oh,
is something like a packing now. This function is packing now.
okay, okay, okay.
This function is packing. So first of all, the decoration I'm giving. Suppose when you are purchasing the gift is packing with one thing. One function is already available, but that is inside of the main function. Okay, this is the function. This is wrapping with the timer decorator. But you are calling the this one only. The major one is this one only. This is the value basically.
Right.
This is the value. The value is packing with the start time and end time.
Okay.
This is packing with the decorator. Packing with the decorator means this is having some wrapping, a wrapper. See, when you are purchasing the gift, you are wrapping the gift, na?
Yes.
In the same way, so wrapper I need to define for the decorator. So this is the syntax for the decorator. Wrapper is important. Okay, and
Okay.
for wrapper, what I'm this name is your wish. Whatever you want, you can do. Wrapper function, something like that. But inside that, I am actually keeping the value, keeping the main value, keeping the main value. In the decorator, I am keeping the main value. This is a kind of gift packing kind of situations.
Sir,
Just
while executing, while
yes.
executing, first, can we come line by line, sir? Just confusing this thing, having confusion.
First, you see this one. First, you see this one. First, you see the previous program. See the previous program.
Yeah,
We have say hello function, right?
yeah,
We have say hello function here.
yes,
So say hello function is the main function, original function, right? This is the
Correct.
value. This is a ring. This is a gift. Okay. I want to pack this gift with the decorator. I want to pack this gift with the decorator. So for that, I need to take a paper. Okay, paper nothing but a decoration paper. Okay, whatever it may be. So for the decorator paper, first of all, in the decoration paper, I need to keep the gift, keep the value of the original function, some parameter, whatever it is. Alias, say hello, alias.
Right, sir.
Okay, alias. Okay, so this is actually not needed. Okay, wrapper function is required. So wrapper function started. So packing is started. Packing is started. So when the packing is starting, first of all, inside the packing, this is also not needed. This is also not needed. For your understanding purpose, I'm just in the packing only original function I'm packing. In
Correct.
the packing, I need to keep the value. And the pack is execution. Pack is executing that. But you need to finally end of the day, you are focusing on the value or not.
Yes.
You have the value and your value is packing and call the main function. When you call the main function, first of all, this function is packing with the wrapper function. This function is packing with the main function, a decorator function.
Even if you won't call the main function also, it's fine under the decorator function.
Main functions compulsory we need to execute. Now this program we need to execute. For this line we need to execute. Otherwise, this decorator function will not work out.
No, I mean to say under the wrapper function, we are
Hmm.
calling function original function.
Hmm.
Even if you don't call also, is it fine or else this is
No, no, no,
mandatory?
no. You have to call. You have to call. That is the reason, right? We are packing the value. Without value, what is the paper use?
No,
You're
no. The thing is like, sir, in the first line you have written a def decorator function. In the
Hmm.
bracket, original function you have written,
Hmm.
right? So
Hmm.
I'm thinking in this way. In the first line itself, it goes to the say hello function and will get the output,
No,
and
it will not. It will not come like that.
it won't come.
It,
Okay.
it, it is this say hello whatever you are writing here. This is alias of the original function. You are
Yes.
taking as a parameter. In the wrapper function only, you need to call the parameter, then return the wrapper function.
We
This is the
can't
packing.
consider
This
it.
is the packing, sir. This is the packing. Wrapper is the wrapping the value, wrapping the value. What value? Wrapping the value. What value? Say hello value.
Say hello.
Say hello is going to be taking as a parameter. The parameter is getting executing. That's it.
Fine, sir.
Okay. In the way we have the one more example like timer. Same decorator is there, wrapper is there. In the wrapper, some time is starting, time is ending. But before time start time under, what is the time? What is the your time? Your time. My sleep time is only 2 seconds. I'm calling the 2 seconds here. I'm calling the 2 seconds here and start and go for 2 seconds and end. That's it. Start the time, go for 2 seconds and end. There is a functionality I'm writing like that. So that is a very reason. So the function is executing done and execution time is this. For example, here I'm giving 6 seconds or 5 seconds. This will wait for 5 seconds basically. This will wait for 5 seconds to analyze the data, and execution time is 5. This is the way you can able to work out with the decorators. Don't confuse. You can see multiple programs with the decorators, then you can understand how the decorators are. Just understand the concept. That's it.
Okay,
It's a
Mohan.
it's a simple thing. General way, you have the value, you have the gift, and your gift is going to be packing with the paper. That's it. Decoration, nothing but one function is decorating with another function. One function is decorating with another function for execution. Iterators are simply different. Iterators are basically, an iteration is an object that allows iterator over elements one at a time using by the next keyword, Python keyword, that is a Python keyword. Okay, an object iterator, an object iterator. This is some kind of step by step. This is some kind of step by step. First, wake up in the morning, stop the alarm, go to washroom, then go to meditation, then go to gym. There is one functionality in the morning functionality. Morning, whatever your morning time things, do one by one. Do one by one. This is a kind of loop actually. One by one, you are going to be iterating the values. But one after another, I need to execute means I need to give the iter. There is a method called iter. There is a method called iter. How to write iter? Double underscore iter. This is the keyword. Double underscore iter. This is the keyword. This is the function. Iter function. And whenever the iter function is going to be working, and this returns itself at the same time, after iter function, compulsory we need to call the next function. Next work. This returns the next element. So iterators are working with the two important functions element. Iterators are going to be working with the two important functions. One is the iter function, one is the next function. Very simple, straightforward. I will tell you one small program. I will tell you for the iterator and generator. Generally, we know loops, right? Generally, we know loops. The same kind of concept, but little bit different. Writing pattern is different. For example, I am taking some numbers here. Numbers 1 comma 2 comma 3 comma 1 comma 2 comma 3 comma 4 comma 5. Okay, I'm just writing some numbers. Okay, iterator it is a keyword. For example, I'm taking variable is equal to iter. Iter is a function, and I'm taking a numbers as a parameters. Nums. Okay, just observe. It is a keyword. It is a variable. Here it is a variable. Iter value or itv is the value. And iter numbers. Sir, I'm not writing any loop here. Without loop, you can print the things. Next, print next of itv. What is itv? Execute it. If you execute it, what is output? Only one. Sir, when you go to loop, all the values are looping, right? But without working with the loop, I need to iter only. These are the morning works actually. First work, second work, third work, fourth work, fifth work. I want to iter only 3 works. I don't want to work with the 2 works. I complete 5 works. Okay, I just want to finish the 3 works and I need to go to office early morning. That's it. 3 works I can able to execute. Fourth work, fifth work, I don't want to go. So that is customized looping, customized doing things. But compulsory it will go for the next. When I call the next, automatically it will go for the next iteration value. Getting my point? Not getting understand? Sir, there is a loop, sir. For example, the same numbers, if I keep in the loop, what is happening? Num for num in nums. When I say like this, what is happening? All numbers need to execute. All the workouts you need to execute. 1, 2, 3, 4, 5 within short period. All the functions are executing. So you have the dedicated programs. That dedicated programs one by one you need to execute. You go with the loop. But my situation is different. I have number of works today, but I need to finish only 3 works. So first work is this one: iteration value, iteration value, iteration value. That's just go stop. If you don't want to do all these things, only 2 values you have to do. Just go with 2 values. If you want to do 5 values, you can do the 5 values. Okay, I need to finish the 5 values. Print the number of prints here. I need to do the 4 values. Go to the 4 values. Customized one. Customized loop basically. Customized loop. Loop is different. Loop is going by index, but this is not going by index. There is no function here. Just iter values. Just iteration is going on. But whenever you are entering into the iteration, you need to go with the next function is important. Next function is important. Without having the next function, that iteration is not going forward. Am I clear?
Mohan's one query.
Go ahead.
Here for the first print, next of IT underscore V, why it is taking 1 as a output?
We are in iter. I'm calling numbers, right?
Right.
In iter, I'm calling numbers. In the numbers, what is the first work you have to do?
1.
One only. That is the reason it will take 1.
Okay.
Starting from beginning.
In another way, from where the actual function, I mean, where the actual concept is starting, is it from the print or else from the nums?
No. It is starting from iter. Iter.
Okay, that means already IT underscore V is already having 1.
Iter nums. Iter nums. Okay. Iter nums means it is ready to take 1, 2, 3, 4, 5. Iter is actually ready to take 1, 2, 3, 4, 5. Okay, it is ready, but I don't want to go for all the works. Go with the first work. First work means what? When I say next, first work only starting with. Next means start the work. Start the work. Okay. Now, when I say iter, it is actually ready to take all the numbers. It is ready to go with all the works. But after the first work, I am tired. I can able to stop it. Okay.
If
If
you
I want
print
to go for
only IT underscore V, Mohan,
IT underscore,
for the first print itself, IT underscore V.
it will give error. It's a variable, just a variable. It is a list of iterators. I told you.
Okay.
Iter function already taken all the numbers. All the numbers means all the works as a list. It is
So
ready.
to print it, next is mandatory to use.
That's mandatory. That is the why reason I'm telling. So iter returns itself. Next returns the next element. Here I'm writing the theory now. Iter return itself, and next returns the next element. Next element means what? Here the next element is 1 only. Next element 2. Next element 3. Next element 4. Next element 5. These are keywords. Remember, iter is a keyword, and next is the predefined keyword, predefined function. Next is one thing, and iter is one thing. These two are compulsory. Whenever you are using iter, you have to compulsory use the next. Customized looping process.
So that variable T underscore V always holding the latest value.
Latest value. Yeah, ITV is going to be storing the 1, 2, 3, 4, 5. Actually, ITR
Correct.
numbers. ITV is going to be storing all the values 1, 2, 3, 4, 5. But what you want to do? First ITV is getting next. Next ITV is getting 2. Next ITV is getting 3. Next ITV is going to be 4. Next is going step by step. Next is countdown increment. Am I clear?
Somewhere after some 10-20 steps, 10-20 statements also, if we print this next ITV, it will hold the latest value, right, Mohan?
Obviously, latest values until the numbers completed.
Until the numbers comes, yeah.
Until the numbers come. Same like loop, sir. Same like loop. But loop is different. Loop is executing all the data one single
At
shot,
once. Yeah, yeah.
one single shot. But this is not like that. This is based on your requirement. You
Yes.
go with the iteration. So there is a one more important thing, like yeah, this is a okay, going down. Okay, 1 2 3 4 5. After 5, let me try to go with iteration. After 5 values, let me go with the one more iteration. Sorry, copy this, paste here. After 5, I'm trying to iterating the one more iteration. Stop iteration. There is no iteration value. The last print is not executing. Why? Because there is no value inside this nums. There is no values available with the next keyword here. This next function is not able to get the iteration value. That is the reason you got the error stop iteration. Stop iteration. So go, don't go. Why? Because 1 2 3 4 5 enough. 5 iterations only it can do. 5 iterations only it can do. 5 or less, whatever you want. Am I clear this?
Yes, Mohansh.
Next, we will be having one more concept called a generator. Generating. Memory efficient. Does not store all the values at once. Lazy evolution. Value generated. Value generated on demand. Okay, so it is a very important concept, like memory management kind of thing. Generator is very important concept. And what is the use of the generator? And this is basically generator is memory efficient. Yes. And one more important, does not store all the values at once. Does not store all the values at once. That is a major important point here I want to tell you. And this is some kind of lazy evolution. Okay. Let me go with the simple program for this. And here there is a keyword called yield keyword. For example, there is something like a sample generator. Sample generator. There is a function I'm writing like sample generator. Okay. I don't want to write anything here. Just go for the yield. There is a keyword called yield. Yield one. Yield one is the value. There is a value called yield. So this function containing a block like yield. Okay, so now if I want to go with the loop, now generator is going to be having a value called 1. Okay, for I or value in generator function. How many values are there in generator function?
One.
Okay, print value, yield 1. Only one is going to be printed. Why? Because this generator function is going to be having the yield 1. Okay, just go with the yield 2, and yield 3, yield 4, yield 5. Based on your requirement, you can create a generator. Okay. So how many values are yielding now? 1 2 3 4 5. 1 2 3 4 5. Each yield passes the function and saves its a state every time. Okay, when loop is running, it will take some memory. Why? Because of whatever the number of values you are actually giving for the loop, it will occupy the complete memory. But here it is not like that. First of all, if I execute the only for one yield, that memory allocated only for the simple value called 1. This generator is going to be having the only one value right now. Okay, one value enough. Just it is going to be taking the memory, a less memory. And for example, if you want to increase your value, see, based on work, your time need to be allocated. Based on the work, your time need to be allocated. But Without having the work also your time is wasting means what? That is nonsense, right? That is the why reason generators are actually concepts in Python. Generators are actually a concepts in Python. Okay. So using by this generator, everybody got understand? One more simple example I will tell you based on this yield concept, generator concept. You know Fibonacci, right? You know Fibonacci. What is a Fibonacci? There are 1, comma 2, comma 3, comma 4, comma 5. So what is the Fibonacci number, sir?
135.
First of all 0, then 0 plus 1, 1, then 1 plus 2, 3, next 3 plus 3, 6, then 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21, something like that. I want to go with the Fibonacci's. So Fibonacci numbers I want to print for a few numbers. For example, let me go with the Fibonacci numbers. Let me go with the Fibonacci numbers. Def Fibonacci. This is also working with the yield concept actually, like a generator concept. I am taking the Fibonacci. There is a value called n. I am taking a n number of values. Okay, so I'm taking a comma b, two variables I'm taking. A comma b is equal to 0 comma 1. Two values I'm going to be taking inside the function. Then for in range of n, for in range of n, I don't know about the range of the n value. So here I'm taking the n value range, and then yield a, just yield a, only a value I need to take. Then a comma b, sorry, yield a, then enter. Sorry, what is happening? Okay, yield a. Then after that, I need to go with small a, remote. Why it is taking address? Okay. Then after that, I just want to get the values a comma b is equal to b. Then b comma next value is a plus b. So a is going to be storing with the b value, and b is going to be storing with the a plus b value. So this is multi-value assignment. You know multi-value assignment, multi-variable assignment. A comma b comma c is equal to 10 comma 20 comma 30. This is the multi-variable assignment. You know that. Suppose what is the a here? 10. What is the b here? 20. What is the c here? 30. So this is something like a multi-value assignment. You need to remember the multi-value assignment. At the same time, I have the multi-value assignment a comma b is equal to 0 comma 1. I am giving two numbers here. Okay, yield a only, and a comma b is equal to a is going to be storing with the b is going to be storing with the a plus b. Then finally, I want to write a for loop. I want to write a.
I didn't get the fourth line for underscore in.
Wait. So and num in Fibonacci, I am taking the 6 or 7 numbers. 6 or 7 numbers. This is something like anonymous value. Yield is something like I don't care about the value here. So you can take anything. Why? Because I don't have any value I'm printing here. I don't have any value I'm printing here. There is no value need to be defined. This is something like anonymous value you can take. Now you can call the Fibonacci with 7 numbers. Then you can go with the print num. I want to take the num only, and Fibonacci is going to be printing like a 0, 1, 1, 2, and 3, and 5, and 8. This is anonymous, just underscore. When you say underscore, anonymous value. When you say underscore, this is anonymous value.
Okay.
Okay. and in range of n. What is the n value here? For example, I'm taking the 10 value. I'm taking the n value as 10. So immediately what is happening? Fibonacci 10. Fibonacci 10 means Fibonacci here, Fibonacci 10. Fibonacci 10. And I want to take two imaginary values. Two imaginary values like a comma b is equal to 0 comma 1. Imaginaries. 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 Okay. Then I am writing the loop to go with the Fibonacci functionality. Fibonacci functionality. How the Fibonacci functionality? So here n value you are going to be passing yield a. Only a value I am taking here, and a is equal to b, and b is equal to a plus b. It is the next summation, right? Yield Fibonacci is next summation I want to get. So that is the reason this Fibonacci is going to be like this. Okay. 0 is there, and 0 plus 1 is 1. 1 plus 0 plus 1 is 1, then 1, and 1 plus 1 is 2, then 3, and 2 plus 3 is 5, then 5. 5 plus 8 is 13, 13. 13 plus 8 is 21, 21. 21 plus 13 is 34. It's like a Fibonacci series. Just a simple logical. So for Fibonacci series also, I want to go with the yield function. In the number of cases you can use this.
What is the use of yield? I didn't get.
What is the use of yield? Without
Why we use it?
without executing the total number of values in the loops. For example, there is a for loop, sir. For loop, when you initiate the for loop, range of 20. Range of 20 means what? For 20 values, it is going to be allocating the memory.
Right.
For 20 values, it is going to be allocating the memory. Okay, I don't want to go and assign the memory for the 20 values. Based on my requirement, I want only one value execution, go yield one value enough. Or I want to go with the two values, yield 2. I want to go with the three values, yield 3. Your function is there, your for loop is there, but your for loop is generating one by one, step by step. That is called a generator. Generate 1, if you want generate 2, if you want generate 3, if you want generate 4, if you want generate 5, something like that. So these decorators, generators, iterators are simply tricky process. That's it. In Python, in general way you have different kind of concepts. Those concepts you can understand, but these kind of concepts are basically tricky processes. Okay, so generator is one tricky process, iterator is one tricky process, and decorator is one tricky process.
So while using generator, this yield is mandatory to use.
Compulsory. Generator yield means stop it. One value, stop it. Two values, stop it. Three values, stop it. Don't allocate the memory for the for loop with the bulk of the values. Just generate one by one. So some work, some energy. Next work, some energy. Next work, some energy. Step by step process. Generator is something like generate one by one. Generate one by one. Don't give the petrol for all the values at the single time. Just give the petrol how many kilometers you want to travel. That is a simple scenario I want to tell you. Just give the petrol for the bike how many kilometers you want to go for. I don't know about my work today, but I fill the tank full tank, wasting my money. I don't know. I don't have any works for the next 10 days. I don't care about it. But first of all, I need to fill up the petrol to my bike. Instead of that, today my work is going to office and coming to room. 50 rupees petrol is enough. Just pour the 50 rupees petrol into the bike. That is a kind of concept. Next day 50 rupees. Next day 50 rupees. This is a kind of generator concept.
A concept I understood most like if we come to Fibonacci, right?
Ah,
Uh, Below
yes.
here, how the yield is working, I didn't get that. Why, whether
Here,
it is incrementing the a value or how it is? We are nowhere incrementing the a value.
no, first of all, 0 and 1, first of all, we are taking the, can you
Correct.
see?
Yes, yes.
0 is going to be initializing with the A, and B is going to be initializing with 1.
Yes.
So by default, I'm taking some imaginary data.
Yes.
So based on the imaginary data only. So first yield A. Yield A means 0 is going to be printed, something like that.
Right. Right.
Then immediately what I want to take the B also. A comma B. B also what? What is B? B is A plus B. Existing number, then plus next number.
Okay.
Existing number, then plus next number.
Okay.
Okay, Fibonacci you pass only 5 values. Okay, it will take 5 Fibonacci's only. It will not printing like a number of things. 5 Fibonacci's.
If
I'm
that is the
printing the
case,
number.
0 plus first one 0, 0 plus 1 1, 1 plus 1 2 should come, right? 1
0
plus 2.
plus 0, 0 is there. 0 plus 1, 1. Okay, then 1 plus 1, 2. Then
Double
2,
time
1.
1 came, right?
No, not double time. First of all, 0, sir.
Yeah, first
0,
0.
0 plus 1, 1. 1 only.
Yeah.
And 1 plus next 1. 1 plus 1, 2. 1 plus 2, 3. Can you go like this? Can you go like this? 0 plus 1, 1. Then 1 plus 1. Previous value and existing value. And previous value and existing value. Previous value and existing value. That is actually Fibonacci.
Okay.
In that way, Fibonacci is working. And Fibonacci functionality is like this. Two imaginary values we have to take. Previous value and current value. Previous value and current value.
Got it.
Got it. So, sorry, that is what actually the 3 functionalities. And tomorrow we will see about the files in Python. Okay, just do practice more and more examples on this. You can get it out. And please like the video, share the video, subscribe the channel. And tomorrow we will go through the file system. File system is very, very important in Python. That is a different concept. And these concepts you do practice with the multiple kind of examples, you can be able to understand.
Hello.
If you want, you can read the theory for that. Okay, read the theory
Hello,
wherever
sir.
you. Yes.
Hello. Am I
Yes, yes,
audible?
yes, I'm getting you.
Sir, can I get a recorded session?
Yes, all the recorded sessions are available no? In the YouTube channel. Who is talking? Mahesh.
Okay. Yes, I'm Mahesh.
Mahesh, you are joining today
YouTube
first.
channel. Okay.
Today you joined. Huh?
Yes, sir. Yes. Today only I have joined.
All the recorded sessions are available in the YouTube channel, Mohansh Technologies. You can just go and watch.
Yeah. Okay. Thank you.
Notes I will share with you. Just provide your email ID here. Provide your email ID here. I will share the notes.
In
Give me.
Drive, can I get in
I
Drive?
will. I will share the drive. Please provide your email ID in the chat box here.
In where I have to share my email
Sir,
ID?
here some chat box is available in the
Lab cutting వెళ్తున్నా కదా
Chat box.
రిటర్న్
Yeah.
chat.
Okay. Thank you.
Go to meeting chat.
Oh,
వస్తుంది షుగర్
Can you see? Go
షుగరే
to
కదా
meeting chat. Mahesh, can you see? Go to meeting chat here. Mahesh, are you available?
Yeah, he provided the Gmail.
Yes. I got it. Yeah, Mahesh, I will share the G drive to your email ID. Just go through the notes and recorded sessions are available in the YouTube channel. You can go through the YouTube channel, watch one by one all the sessions, whatever we have till now so far. Right? So bye for now, guys, and we'll meet tomorrow. Have a good day.
Thank you, Mohansh.